Welcome to class number 6. Today we're going to cover um, functions and a little bit of complexity in those functions. So sometimes in Python we call them methods as well. So those are used interchangeably. Some technically there is a difference, but for typical work operations, you can use the words function and methods interchangeably. To start, let's look at how do we define a simple function. So when we define a function, so we use the def command, and then we put in the function name. In this example, we're using the name called plus. Insert it, we give the parameters that we are passing to the function that we're defining. So for the example, this one has two parameters, a and b. Sometimes it's also called arguments. Typically, according to like the definition, when we define a function, these are called parameters. So it says parameter a, parameter b, and when we actually call the function, those are called arguments. But those have to match the parameters that the function defines. Say for example, this one is 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 uh, is an argument that fits the first parameter in the function, and this is in second argument which fits the second argument or the second parameter in the function. So we're going to define a function plus, and we're going to pass in two different parameters. So we don't really specify if it's going to be an integer or a float or or a string. We don't have to, but there is a way to do it. So when we define it, we given like two parameters, and here this is called a doc string. When we use three triple quotes, and then we start a set of lines, and then we put in whatever this function does. Python stores this as a doc string. So this function, if somebody wants to know what it does, so if you read this, it says adds two numbers. So it provides that value here. So it pulls it from here and it stored it as a doc string. And that's why you see it whenever you go to the help for the function. It says function, it's a plus. It takes two parameters, a, because we're not defined it should be an int. It takes any kind of parameter. B, any. That means it passes any kind of parameter. And then it returns this one is the doc string value that we pass here. So if I change this to say so if I pass this to actually say a different thing, then if I go back here, so it changes the value here. It does the return value. Whatever I put in here comes out there. So this is called the doc string value. And a return statement is one of the statements that returns the value back to the function that called it. So here we'll try calling the function. This return statement, what it will do is it will end the processing of this function and then return the value here. What that means is if I have a print statement here and say print all done, this would never get executed, like, because it is after a return statement. Anything after a return statement you do will never get executed. So let's try executing this function. So whenever I execute this function, please note that nothing happens. What that means is unless somebody explicitly calls this function, say for example you have a file where you define a function but you never call it, that means that function is never going to get executed. To actually execute it, you have to call it. and you have to call it like you have to use the function name, open the brackets, and then give in the parameters. So here we have two parameters, and I give plus 2 and 4. That prints out it returns the value 4 plus 2 or 2 plus 4, that is 6. It prints it out here. In case I try to like given the wrong values, say for example I give only one value, then the method would not get executed because it's missing one positional argument b. So I'll quickly get into what a positional argument is, but right now we are thinking that the first positional argument is there, but the second positional argument b is not there. Say if I give 3, then it's going to error out saying it takes two positional. This function plus takes two positional arguments, but 3 were given. Say I given a string 3 here as well, we like it's going to error out because we don't have an int and string operand. If you send one int and one string, this function is not able to process it, and we're not able to get back a valid option. So I told you about the doc string. So there is an internal function or the built-in function that Python has, so which is called doc. So that one, that document that would actually print the value that we gave in the doc string. So whatever we listed here is stored as the doc string, and then you can print that out. When you want to know what the function does, you can print it out using the doc built-in function. So these are called dunder functions. So if you want to understand a little bit more about dunder functions, there's a Python advanced course out there in YouTube. There's also a link in the description below. You can check it out. We talk about these dunder functions, including this doc string. But these are especially important when you get into a little bit of like reusability of functions and like calling methods using two different use cases and stuff like that. At that time, you'll probably go into those advanced cases. But if you're just still a basic follower, keep going along, and then you can find the advanced courses a little bit later, and you can use them. It's on the description below. Next, let's look at why do we use functions. So why would I ever use functions if I can actually write code that can do what I can do without actually using functions? So functions are a way to do certain things multiple times. For example, what we did here, we wanted to add two numbers, and we wrote a function called plus. Say if in my program I have to add multiple numbers, add two numbers 100 times. So each time, if you want to write this logic, that would probably be like repetitive. Rather, if you use this function and then call it, that would make it simpler. Yeah, for a one line logic, it doesn't seem like to make sense. Say if this function has like 10 lines of execution, and you're doing it 100 times, so that would mean 10 times 100, you're actually writing 1000 lines of code, and then you're executing all those 1000 lines of code. Rather, execution of those 1000 lines of code does not matter, but maintaining that code with 1000 lines is going to be really difficult. Say you want to change the logic in those 10 lines, like one of the lines you want to change, and because these 10 lines are repeated 100 times, you'll have to go into all those 100 places where this is there, change it. A lot of work. There, it's also prone to errors. So that's one of the reasons we try to see whatever is reusable, whatever code we rewrite multiple times, we try to use a function for that. And uh, using a function helps in a way that when you maintain the code, you don't have too many lines of code to maintain. And if you want to change a logic, you change it in one place rather than changing it in multiple places. So it avoids the error that could happen because of that, because of like missing out one place or changing it incorrectly in a place. um, so it avoids, I mean, this one avoids the maintenance issues. If you want to write a like code without functions, say for example I have two lists, I want to find a sum of elements in the first list, and I want to find the sum of elements in the second list. So for the first list, I say for item in A, sum equal to sum plus item, print sum. So it's a simple for loop. I start with sum is 0, and then I keep adding each item in the um, list to the sum. And at the end, when all the items are done, the for loop is done, then I print the sum. Okay, very nice, it will work. I want to do the same thing for B, so I do the same thing, similar loop. Only thing that is different is I ask for item in A here, for item in B here, and then I print the sum. So if I do this, I get back like the two values I wanted, and it's pretty good. Tomorrow I want to add one before I print this out. So here I say sum. I mean, I want to add one time before I print it out. So I say sum plus equal to 1, and I want to do the same logic here as well. So I have to do this twice. So when I make a change, I have to do this twice. So this logic works, but I have to make the changes in two places. If I did it using a function, the way I would do it is I would define a function. I would define a function. Let's do that first. I'll define a function plus, and I'll take in a list, and then I will look for any items in the list and then add one, and then I'll return the sum. And when I print plus A versus plus B, I'll get two different answers here. And tomorrow, if I want to add one more element here, sum plus equal to 1. So I add it only one place, and then I execute it. So I get the same answer here, but I didn't have to make this change in multiple places. I just had to do it here within the function, and then whenever somebody calls this function, this gets executed. So that's the beauty of using functions. When we actually use classes and methods, um, this part is going to be really useful. So let's dig a little bit more deeper into functions. I'm talking about functions a lot, but what we have been talking until now is actually user defined functions. That is you or me or any other programmer in your project defines the function, and then that gets used. But we've been using Python's built-in functions all the time. I mean, if you look at this, if you want to find the length of this list, we use length of A. This is a existing built-in function. So if I go here and see the help for that, so it says it's a function. It takes in an object, and it returns back an integer. It, it returns the number of items in a container. So it not only accepts lists, but it also accepts other types of objects. And then it would actually find out what type of object it is and then find the length of it. For example, like S is a string. If you want to print the length of the string, that in itself is a function. But not only length, I mean, we've been using print all the time. So print is also a function. So print, and then we open brackets. So that is also a function. It takes in like a lot of values, and then it does not return anything. So whatever comes after this arrow says what it returns nothing. And I'll tell you what this single star means. But print, when you give print and then you give like you give anything inside it, that gets printed. And today we're going to cover this single asterisk. So those are, if you don't know how many arguments are there, you pass it using, I mean, you define the function using a star asterisk, and so we'll cover that today. So just to get back to the point, we've been using built-in functions like length, print since the start of the class, but because those are built-in functions, we don't have to really define them. Like if you look at this, you can actually find how it is defined. So it has been defined as a like as a function. It takes multiple values, it returns none. So we know all those things by looking at this, and you can look at the doc string here. So this one is the doc string. It tells you, it gives you an explanation of how the print works. So the developer of the print function wrote this doc string for us so that we can understand what it is. So if I execute this, this is going to print the length of this, and the length of this. And both the print and the length are built-in functions that we use when we ran this. So similar thing that's happening here is length of Wonder Woman. I think we did something similar. So it's 12. It includes it. And then we look at a tuple, and then we call the like reversed. Here it's actually a class. It returns a reverse iterator. So the return value is actually an iterator in itself. So when we take in a tuple or a list, and then we call the reversed function, and then we call the tuple function back, we would get a reverse value of that back. Again, these are all built-in functions. Reversed tuple builds a immutable sequence from the values inside. So those two are existing functions or built-in functions that we use. As I said, print is a built-in function as well. Here I'm doing the same thing with the string, but I'm using reversed in tuple. So when I reverse it, it reverses the whole string into a tuple and then prints it out. So I can do the same thing for a list as well, just like I did for a tuple. I can reverse it. And I was talking about doc strings. So when we want to print, you want to understand what reverse does, you can print the doc string for it to see what it does. Okay, they gave in a one-line explanation for this reversed function. It returns a reverse iterator over the values of a given sequence. So if you want to like do it for list or tuple, you'll get what they have defined in that definition. So you can see that for list, they've defined it as a built-in mutable sequence because list is a built-in function, and you can see whatever is listed below also listed here. That is the doc string. So now we understand that we've been using functions all along, but those are called built-in functions. Let's get back to the user-defined functions. That's more of what we are going to, as developers, we are going to be writing user-defined functions all the time. And so let's get back there. So when we write a function, say this one is a +1 function, we define the name here, we given the parameters inside, we write the doc string inside, we do all the processing here, and then we return the value back. If there is no value to return, like a print function does not return anything, it just prints something. It doesn't return it anything back to the variable. So if that is the case, we give a return. If we want to return something, we use the return statement. But if we're not, we don't have to use a return statement. And to know that your code is your function is ended, just go back a tab and you can do any kind of processing here. A is equal to 1, print A. So this when this function is defined, we know that it's defined until the time there is the tab is returned back to its original value. So anything that's here or to the right, like for example, you have a for loop here, I in range of 11, print I. So anything you do there, anything you do here would still be part of the function. So anything you do here would still be part of the function, even if it's indented to the right. So as long as you get back here to the same level, and the first level line that does that would be would mark the end of that particular function. Okay, so let's run this function. As I said, when you define the function, nothing is going to get called. We're not calling it. It just prints this value. So let's say x is equal to +1, and then we're going to print x. So here I defined the value, defined the function +1. Say I have like multiple lines of code in between, and then later someplace I'm calling x is equal to +1 of 5. So all this function does is it adds, this is the input parameter that we are getting passed, that is here it's n. So we are adding 1 to that parameter and then we're returning it. It's also doing some print statements. I don't want to do that, so let me take that off. Let me rerun this so that the function gets redefined. Now when I call this, it's actually going to store the value that got returned in the variable x. And when I print it, then I know that it's now 6. So now I just want to show you that say the same function, when I have a print statement in between and it's printing like the values 0 to 10, but it's because it's inside the function and I'm not calling it here. When I execute this part, it's not going to actually print these values. But here, when I actually call the function, I'm going to get those values printed out. And when I actually print the value of x, I print the value 6. So anything that happens within the function does not get executed when we define the function. Only happens when we call the function with a parameter, or I mean, depends on how many parameters are there, whether the function has a parameter. The function need not have a parameter. Function can be can have an empty list of parameters as well. So depending on that, and then when we print, I mean when we store the value in somewhere, or when we print it, the return value gets stored there. So anything that we use in a return statement, that gets stored there. Say if we don't have a return statement, when I do this, when I try to print it, I don't get any value, or Python tells me there's a none value. And the reason is we did not have a return statement. So that's very important to understand. So the return statement is going to return values only when there is an actual value that we send in. So now when I print it, I'm going to get back the value because I restated the return statement here, and the return statement is going to return the value. So we wrote a doc string. Let's see if we can actually print our doc string that we wrote so that it prints it out. So whatever we defined here in the doc string, how many ever lines it is, everything gets printed out here when we actually use the dunder function called doc. Now let's get into a little bit more trickier items within the function. I spoke about functions having arguments or parameters that get passed. We could have one parameter, multiple parameters, or we could have no parameters. But that's something we learned about. Um, let's in real life we write a function and then we could call it multiple times. Sometimes we know what the arguments are going to be. Sometimes we might pass like 3 arguments. Sometimes we might pass like 8 arguments, and we want the function to be able to do stuff based on like what arguments we pass. Say for example, I have a list of all the kid names, and I want to print the list of kid names, and I don't know if it's going to be like 1 kid, 10 kids, 8 kids. I don't know how many it is going to be. So when I define the parameters, I use the single asterisk, and whenever I use a single asterisk, it will assume it's a tuple, and then it will pick whatever we pass here will be a tuple, that is multiple elements separated by commas, and that will get stored in kids or any like if you use args here, which is default. Like a lot of functions use args. So when I use arguments or args, I give this here, and then I want to print all these elements in args. I just print it out. So here if I have like 3 more elements or 1 more element, I don't have to change my function. I just add more things and the function still works. So if I want to have flexibility around that, I use something called args. And there's also something called quags. So these are typically called args. There's also something called quags. So whenever you still don't know how many arguments are going to be there, but you want to like name your arguments a certain way, and in those kind of elements, we will actually look at something called quags or keyword arguments. So what are keyword arguments? So keyword arguments are where if you can have multiple keyword arguments, but you don't know what keyword arguments you're going to use, then we use something called a, a list of elements, and those get passed as a dictionary, and then we will pick whatever we need, and then we'll use it. So for example, here in this function, we are writing a my function, and we're defining it such that we have keyword arguments. That is, I'm using double asterisks. What Python would do is it wouldn't take it as a tuple. It wouldn't take the input as a tuple. It will take the input that we give here as a dictionary. That would mean there's a keyword f name, first name, which is this one, keyword l name, and then it will be this one. So it will pass in those values as a dictionary. So my function would now have a dictionary passed between this, and then we will just print out the last name. So, and how we find the last name is in a dictionary. If you remember, we use square brackets, and then we use the actual name, and then we'll get the value. So the name here is L name. If we use that, we'll get the value Kumar. So if we run this, it prints out his name. His last name is Kumar. So this is one use of the keyword arguments. I did not have an example here, so let me write this down. So we need to understand what are positional arguments and keyword arguments. So when we write a function, my function, and then if we have two parameters in it, and say we return a plus b, so that's a simple method. When we call this method, we could call it in multiple ways. So let's say I'm calling it using positional arguments. That is a typical way of calling it. So what would that mean? It will mean just I just give two parameters. I don't specify any name for these parameters, and I just call it. That would mean Python would take the first position, assign it to the first parameter that we have defined, second position, and then it'll take it to the second variable and it'll assign it. So those are called positional variables. Instead, if I say b is equal to 1 and a is equal to 2, that means I'm using the first position to pass the value of b and second position to pass the value of a. That would actually mean that I'm going to get let's make this slightly different so that say we multiply the first number twice and then add it to b. So it makes the function a little bit different so that we understand how we're using it. So here I'm going to just call it using positional arguments, and here I'm going to call it using keyword arguments. So in both these cases we'll get I'm sorry, I should have printed it. A is equal to, or P1 is equal to, P2 is equal to, let me print P1, P2. So in this case, what's happening is I'm calling my function using positional arguments. That means it takes 1 as A and 2 as B. The second time, I'm actually taking B as 1 and A as 2. So I'm actually naming the arguments. These are called keyword arguments. And let's actually make it slightly different. And then let's have 3 elements to this. Say we want to return this calculation, and when we use positional arguments, I say 1 to 0 and C is equal to 0. And when we use a mix of say I want to take the first value to be 1, but I want the second value and third value to be interchanged. So that's a mix of positional and keyword arguments. And let me print that as well, P3. Okay, these two values seem to be the same. Yeah, that's only because the numbers I've used have ended up that way. So let me just re-execute it. with different set of numbers. So what I've done here is, first time I just called it using position arguments. So Python just uses the first position, maps it on the first one. Second time I used only keyword arguments. So the order does not matter. I actually use the names. So Python knows the names and then uses it. Here I'm using the first position argument for this. I'm not really specifying a name, but these two I'm actually mixing up the order, and I'm actually specifying C to be 20 and B to be 0. Let's do this as well. So let's see. So you can easily see that these became 0 and C is 20. It doubled 20 and then we got 40 here. So we can use positional keywords and keyword. We can use positional arguments and keyword arguments. I will go back here. So here when we saw these were positional arguments, but when we don't know how many are there, then we use the single asterisks. And when we want to use keyword arguments and we don't know how many are there, we don't know how many are going to be called when the actual execution happens, then we use this. And we'll have to look at what function overloading is before we actually understand why you would like how you will like reuse a function and then redefine it to be something else. But that's a little bit of a high advanced topic, which you can probably, if you want to cover it now, you can probably look at the below links. But if not, keep following along. I'll be covering that in a later video. So let's look at the next part of what I want to cover is the scope and lifetime of variables. So Python does not have something called a like global variable in itself. It doesn't enforce it very strictly. So if you define something as global and then you reassign it, it just gets reassigned. So it can be reassigned, but there is some use to it. So this is for people who already know what global variables are and have come from other programming languages. But for if you're just starting out with Python, let's look at what a scope of a variable is and how much it has life. So when I suddenly go and say print B, it will print the B that I had last. So I had B defined somewhere earlier, like long ago I had a B defined. Because I've not really cleared the memory, it's still there. So if I write a long program and I just reference B like below, like 1,000 lines of code, and like the first line has a definition. Say for example, here is B defined, and then I have used B here long later, and then it still has that in the memory. So you can see that when I print it, it still has it in the memory. So the scope is going to be there until that whole Python file is executing. So the whole Python file is executing, it still have that memory location allocated to the variable B, and like as long as the Python file is running, you will still see that the memory value of B has not yet been lost. But does that mean we always have access to the variable? Probably not. I mean, what if you access that variable before definition? That wouldn't work. That makes a lot of sense. But let's look at certain other cases where you cannot actually reference a variable. So say we define a function and then we have the value x defined as local x, and then we print it. So that would mean whenever I call this function, let's break this off here. So I'm going to define this function here, and then whenever somebody calls this function, it's going to take the value local x and then print it. So when I call this, it's going to take the value of local x and print it. After the function is done, now when I call print and I use the variable name x, This is where it becomes murky, because that definition has actually executed. Now the definition is no longer executing. Now when I call x, because x was a variable that was defined inside the function, it was not defined outside the function, or not nor passed as a parameter. So like if there is no if there's no scope for that, uh, what it essentially means is I cannot actually access this, and the scope of x is within this function. It starts since the definition and goes on until this definition of this function ends. So let's try that. um, Here we're getting a value x. I mean, let's use a value x 2 2. And the reason we're getting value x is because I've used this variable x somewhere else in this program, and that's causing an error. That's causing this variable to say that it has some value x as 6, which is not what I wanted to depict here. So let's rewind here. So now I'm going to use a local variable named x22, and that variable is not a parameter in the function. It's been defined inside the function and it ends within the function. That's the scope of variable x. So it starts since this, and then when the function ends, the whole scope of this ends. Here when I'm calling it again, we're outside the scope of that variable, and the memory location is still not allocated to x. So we'll get the error saying name error, x22 is not defined. So we know that the scope of the variable is going to be only within this local area. Say I have another variable x, variable a, and then I pass that variable 1, and then if I try to print uh, this, it's still going to have the same effect. I'm still going to get a name error. That's because I'm using a local variable that was defined within the function, and then I'm trying to reference it. Okay, let's try using the let's try using a variable that is outside the scope of this, and let's start defining with this x33. So let's try seeing what the value of x33 is going to be. So the way we're doing it is I start the whole Python script with the value that x is x33 is going to be global x. Let me clear the values here. So I'm going to say x33 is global x, and I'm going to print the value x33. That means I expect it to print global x, and then I define a function, and then I print. I have the value local x there, and then I print that value, and this doesn't get executed until somebody calls it. So here I call that function. So that means it would do this logic, and then here I'm going to print x33 again outside the scope of this project, scope of the definition. So this is going to actually not reference to this local value, because this local value got defined here and it ended here. Here it's going to look for a definition of x33 somewhere else. So it's probably going to look here and then figure out, oh, here it was. So let's run this up. So you can see that when I do the first print statement, it printed global x. This calls this and it does the second print statement. It prints out local x. And then this statement does not have the reference of this anymore. and we go back to this definition, and then we use that. So we can use the same variable name, and if it's within a function, it will actually within the function have a short-lived value of that value. So I'll give you the last example in this category. Here x is defined as global x. We print it. We're adding a global keyword called like uh, global keyword, which actually makes the x value to be global, and then we use the value local and assign to it, and now we're trying to print it. So the first time it prints, it has the value global x. Next time it calls this function, so it has a redefinition of x to be a global variable. That means its function, its scope lives outside this function. So every time after this happens, it's going to be a global variable, and then it prints it, and then it prints it again. So here we can see that it's going to be different from the earlier execution, where the last execution printed out global x earlier. From here, now it's actually going to print local x, and the only difference is we added this line which actually says global x. That means this variable x is going to be globally available after this. So that's the use of global. I mean, we don't typically use global because it can cause unnecessary issues unless you're a very advanced programmer. Like my seniors always ask me to avoid using global as much as possible. It's difficult to maintain the code because it's complicated logic. Okay, the next and most important topic we'll see are called lambda functions. These are not really functions, but these actually um, return values and work as one-line functions. So whenever you want to have something that your function needs to do, but it's a pretty simple logic, one-liner, uh, we don't have to define a function for that. We can just use this line, and then we can do the whole thing. So for example, what this line does is, if you do def double, and then you take an x, and then if you return x times 2, if you want to do this in one line, then you can take this up and then give the whole thing in a single lambda statement. Okay, so the lambda functions, the way they work is, if you want to define a single liner or a very simple code, you write that as a lambda function, and then we could call double with brackets, just like you would call it a function definition, and then you'll be able to get the value out. So here, this works the same way as we would have done with this def function. So if I take this up and define it this way, and I execute it, I get the same exact value out. So those are interchangeable ways you can use it. But there are multiple uses of lambda functions. It's not just to use it in a single line, but typically it's okay to use it. So here, whatever example I gave here, I think I'm just repeating it using a different value. So when I use a my function n, and then all I want to do is I'm sorry. Let's look at this different way. So this one is a slightly different example. Here I'm actually returning a lambda function which does return a times n. So whenever somebody calls my function with a value n, so for example, this one calls it with a value 2, it actually returns a lambda function. That means it returns another function, not just return a variable, but it returns an actual function, and that function would multiply the value that the new function gets as input. So a is actually the new function's input. A will be the parameter for the returned function. This statement returns a function and it will so we'll look at that in a little bit more. So what this does is it returns a lambda function, and that lambda function takes in a parameter a and multiplies the parameter a with the the value that my function was called in. So at first we're calling my function using the value 2. That means this my doubler itself is a function that will actually like use this as a input, and then it will multiply that by n. So here this portion is n and it's passed on by this. And now when we call my doubler is actually a lambda function, and that takes a as an input and then presents n as an output. So if I want to do it in two different definitions, I would do it. It'll take me a lot more effort. But let's look at this. So the my doubler is my function of 2. My tripler is my function of 3. And when you call my doubler of, like, say, let's do 7. So when we call my doubler of 7, it prints out 14. And when we call my doubler of my tripler of 7, it prints out 21. So if I actually try printing out my doubler, so we know that it's actually a function that's being returned. So my function returns my doubler, but that's actually a function, and we get a function, and it's a lambda function, and it's at this memory location. So you can note that my doubler is actually a function, but it's actually a lambda type function. So we can figure that out by printing what this is. Let's go into a slightly more useful implementation of lambda functions. We use lambda functions extensively when we deal with big data, Spark, Hadoop. So there we use things called map and reduce. So if you're using that, you'll probably be much aware of all these map and reduce functions. But essentially, map and reduce functions take functions as inputs, and then it runs that through a list. So you have a list, you have a function. The first parameter of that is a function. First parameter of map is a function, and the second parameter is a list. What map does is it goes through the list and applies this function to each and every element, and then it returns that back. Um, so especially when you have long lists, using a map function is very useful. Um, but essentially what the map function does is it takes the function as the first element, and then it takes a list as the second element, or any kind of iterables. And then what we do is we apply each element in the list using this function, and then we run that through. So here you can see that each element in that list got squared and then printed out. Reduce, what it does is it takes multiple elements in the list and then like combines them together. Like in this case we are adding them together, but you can combine them together by like finding a maximum, or averaging them out, or any other way. We use that to reduce. We use the reduce function for that. So when we combine values in the list to get one element out, that's when we use a reduce. And if you see, similarly, the reduce takes the first element as a function and the second element as an iterable. So here the sequence is an iterable, and then it returns back one object as a reduced object. So here you can see that the function, then the sequence, and then it gets out the value. Okay, the last concept we're going to look at today is recursion. So recursion is where you call a function within a function. So for one example of this is going to be like when you want to find the factorial of like n factorial, 10 factorial, or 3 factorial, what you would do is if you know 2 factorial, then if you multiply it by 3, you get the 3 factorial. If you know 3 factorial and you multiply it by 4, then you get a 4 factorial. And if you know 4 factorial, you multiply it by 5, you get a 5 factorial. So that's, if you know that kind of pattern where a smaller element of the function would actually help you get the larger element of the function, like the factorial, we would actually use recursion. So that helps you, like when you have to iterate multiple times, and you know that you can actually reduce the bigger function into a smaller function. That is, you can understand that 4 factorial is 4 times 3 factorial. So when you can actually reduce that, then we actually use that recursion principle. So here I'm going to write a recursion function where I define a function FAC. I take an integer. Okay, and this is the way when you want to define the input value should be an integer, use a semicolon, and we want to say what the return value is, use an arrow, and then we say what the type of the value is. So till now we have not actually defined what type of the input parameters need to be, but if you want to define it, this is how you do it. You use a semicolon and then you say int or str, or like whatever you want to do, and then return items. You want it to be a list, integer, string. You define it here. Okay, so getting back to factorial. So when we define a factorial and then we say we take n integers, and then here what I'm doing is when n is not equal to 1, that is, it's not 1 factorial, I'm going to return n times factorial of n minus 1. So when it's going to be 4, it's going to be 4 times factorial of 3. And then when you're calling factorial of 3, you're calling the same function, so it goes back here. Now it's executing 4 factorial. Now it has to understand 3 factorial to be actually executing this answer. So it stops the execution of 4 factorial. It tries to execute 3 factorial. Then 3 factorial gets called and it says 3 times 2 factorial. And it gets here. and 2 factorial also is not known. So it goes back to the factorial here, then it does 2 times 1 factorial, and then goes back here. When it's 1, it comes to else condition, because n is equal to 1, it returns 1. So we know that 1 factorial is 1. Then 2 factorial becomes 1 times this value, which is 2. So it becomes 2 times 1, and so on. So the recursion happens that way. So I've just explained it here with a little bit more detail. So factorial of 3 is what we call the first time. In this example, I'm calling factorial of 3, or I should say FAC of 3. And then it actually says 3 times FAC of 2, and it holds on there because we don't know FAC of 2. We don't know what value of FAC of 2 is. So it holds this value in memory, and then it calls FAC of 2, and FAC of 2 is 2 times FAC of 1. So this whole thing becomes 2 times FAC of 1. And FAC of 1, because we go into the else condition, it returns 1. So we get the value 1, and 1 times 2 times 3, that's the answer. So it becomes 6. So that's the third call. The first call calls a subcall for second call calls a subcall for third call, and the third call has to complete before the second call completes. The second call has to complete before the first call completes. So the whole thing has to wait for all the executions to complete. I've done a similar thing for is prime. So here is a way you check whether a number is prime. And so if you want to use this as integer, so I think that should be the only valid value you agree to. And then okay, so we're calling this is prime, and then we are using integer values as input. So if somebody passes the is prime and then gives the integer value, we'll check if it's 1, and it will check this particular function. What it essentially does is, are you able to find every element between 2 and square root of that number, go through that list, and then if you are able to actually like find anything that's divisible, then it's not a prime number. But if it is, it will complete this for loop, it will come out, this return statement would have broken the loop. If it is not 1, if it's not able to be divisible, then it will come to the end here, and then it will return true. So anything in between, it will actually have broken. If you find any, if they find that the input is 1, it would have broken here. If it did find that the input is 4 and then 2 is actually divisible, then it would have broken here. If it's actually like 5, it wouldn't have broken here, it wouldn't have broken here, so it will come here and then say it's true. So that's a way to do it. Okay, this is a little bit more complicated, so I'll break this off. So I'll just call is prime of 7. I'm assuming that should be true, and if prime of 8 is going to be false. So that's how the program works. And this one is just to find the square root and then add 1. So if it's too confusing, don't worry about it. But all it does is it starts from 2 and goes on until the square root of the number to check if there are any numbers that are divisible. But essentially, when you have a function, you don't know how it works, you don't have to worry about it, you just have to call it. One example is, we saw how the map works. So let me show you how the map works. Let's say prime list is equal to map of, you know that the map takes a function as the input. So here I'm going to give this function, and then you can put in a list or a sequence. So I'm going to put in this list, and then I'm going to print that out. So what that would do is it will take each element of this list, and it will pass true if it's prime, if it will pass false if it's like composite or non-prime. So you can see that when we print it, let me do this. I'm going to print prime list and I'm going to print prime as well. So there's also a function called filter. What it does is it's similar to map, but it filters out elements and only lists out the elements that are actually true. So whenever it passes out false, it will not come out. So let's try that out. So we see that like all those elements are in the map object at this place and or at the filter object at this place. um, I don't want to get into printing that map object and filter object. It's a simple thing. We'll look at it later. But essentially, this prime list has a map object which has the prime values of this. So it will have true, false, 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 true, those kind of things in this element, and it will have a filter which has only the value list of values that are actually passed true out in this value. Okay, today's assignment is for you to look at the kth last element in an array. So when somebody gives you an array like this 3 2 1 5 6 4 and they give you a k value as 2, then you need to find the second largest value in this array. And if there are duplicates, don't disregard the duplicates. Say for example, this has 1, then 2 2s, then 2 3s, then the fourth element will actually be a I'm sorry, like ignore the like duplicate. So it's going to be 1 2 3 4. So fourth largest number in this array is going to be 4. So given an array of numbers, an integer k, return the kth largest element in the array. So you have to find the fourth largest element in this example and second largest example in this example. And this array that you get is not going to be sorted. So you have to you have to find the kth distinct element. Here it says that note that in the kth largest element in the sorted order, not the kth distinct element. But then why is this output 4? 1 2 2, which will be the first three elements, then it will be 3. Yeah, I'm not sure about this output. But yeah, look at this assignment for today and try that out. Like for this example, let's assume that um, like it's going to be this example that matters. So it's going to be the fourth largest element. So you can actually ignore the duplicates, and then uh, like you can actually, oh, I think now it makes sense. So it's asking for the kth largest element. So it's not asking for 1 2 2. So it's going to be 3 different elements. It's asking for kth largest element. So what is the first largest element, the second largest element, the third largest element? So first smallest element is actually okay. Oh, it's asking for the largest element, so I should go from the back. So here the largest element is going to be 6, then it's going to be 5. So the output is going to be 5 here. So the second largest element is going to be 5. Here in this case, the first largest element is going to be 6, then it's going to be 5 5, two of them, and then it's going to be 4. So that would mean 1 2 3 4. Yeah, the fourth largest element is going to be 4, and the fifth largest element is going to be a 3. Sixth largest element is also going to be a 3. So that way, so they want you to like understand what the order is and then figure out what the nth element of that is. That will be today's assignment. Thank you. See you in the next class where we'll talk about class. That's a really important topic when you need to like get into programming, and that's without that it's going to be difficult for you to be able to convince that you're a programmer. So let's look at the classes and the methods in classes next time. That's going to be our next important topic.